when we played in a swimming pool. Maybe you have noticed that there are something like duckball toys, buoyancy in water, and other things not so much. The term buoyancy refers to how well something floats or sinks. If something is able to float, we would say that is buoyant. Now, what makes something float or sink? Generally, we can determine if something can float by feeling its weight. Usually, if something is light, it floats or is positively buoyant. If it is heavy, then it sinks or negatively buoyant. This is an easy enough to explain for us to accept, right? But to understand basic concept, we need to know the concept of density is amount of mass something as relative to its volume. For example, the bowling ball it has a mass more than basketball, so the basketball have a volume bigger than the bowling ball. But because the material is different, bowling ball have a weight more than basketball.
Hi everybody, good morning. Today is first day in the week, and I very exciting to sit near by the fountain. I want to share my feeling with you.
Hey, dude, you dropped my bottle.
Yes, I so sorry, because you lose it.
I lose what?
Your bottle.
Look. My bottle is floating in water because it is approximate empty. It is floating because the weight force influence on water is less than buoyancy force.
How it is floating?
Set now to explain to If I suppose we have a piece of wood have 50 centimeters and 50 centimeters and 50 centimeters solid part was not hollowed out inside will be have the volume 0.125 mm. And the density of this wood 0.3 of the density of water in your opinion. If you put this part in the water the part we be, okay, we must to calculate to know that. Let me start calculate that. First thing we must know how start do any calculation we must make some steps. For it the steps for calculate the buoyancy force are, 1. Draw FBDs of the block and the part. In this step we determine every force influence in our part we need to calculate the buoyancy force for it. 2. Calculate the weight of compare between the weight of part and weight of same part if have water density. Let's go. We can see in FBD we have only two force weight of part and buoyancy force and each force in opposite direction. A is length of part, B, height of part, D. Immersed level we will start to calculate the weight of part that is easy only multiply volume of part and density of part and gravity acceleration. 3. Compare and here we calculate weight of part of density of it equal density of water, then make compare between weight when density is density of water and density is density of wood. If weight of water is bigger than weight of material then part will be floating else will be part sinking. If we want to know how much volume immersed in water we divide the weight of part on row of water and width and length part multiplying gravity acceleration. You can see, we need 3 block of wood to have same weight of water.
Is this all about the buoyancy force and whether there are other things to be calculated?
No, There are many important things like the center of the mass and the center of buoyancy and other things. You can read books related to this subject.
How we can calculate buoyancy force in complex shape and different material.
For complex shape, and something we need to optimize it, we use CAD program and analysis program for it. I will see you example for it. Look. I will see you same part we calculation in CAD. Look, only need make analysis to know volume and density and center of gravity and center of buoyant. This another example for a ROV. You can calculate buoyance force for a lot of things. Oh. We have 2 cube. I think we must make scan for it, to know main properties of it, to know what is will happen for cube won't fall in water. Two cubes are same. Then let's go to calculate it. In this result the cube will be sinking. Let's go to check it. What is wrong in here? Two cube have same properties. But one is floating and another is sinking. What is magic in here? Think we have magic in here, but science is magic. I will make another test to know. To explain what happened in here, I will take cross section for every cube. Aha, one solid and another hollow. Then what for calculation in here? Let's go to check it. The weight of cube changed it, but weight of water for immersed still the same. This question for you. Think before you answer.